Hi there, so welcome back. This is the second part of the lesson on polygons, so 7.4b. This time we're going to have a look at exterior angles in polygons. Our objective is then to calculate the sum of the exterior angles of irregular and regular polygons and to work out the sizes of interior and exterior angles in polygons. Just check through our prior knowledge again then, so things we need to know before we do this lesson. We should know the angle properties of the three different types of triangles, that's scalene, isosceles and equilateral triangles. We should know the angle properties of straight lines and points, so angles on a straight line add up to 180 degrees and angles around a point add up to 360 degrees. We should also know the total interior angles in a triangle and quadrilateral. So the interior angles in a triangle add up to 180 degrees and in a quadrilateral 360. And we should know the definition of an interior and an exterior angle. So an interior angle being the inside of the shape and an exterior angle being if we extend the line, the angle made between that extension and our shape. And we're going to have a look today predominantly at these exterior angles, and we're going to be using this rule that the interior and the exterior angle added together add to 180 degrees because they are angles on a straight line. Okay then, so let's have a look at a bit more detail about these exterior angles. So we've got our triangle. To form an exterior angle, we need to extend the sides of our shape. And the exterior angle is the angle between that extension line and our shape. So we've got those three there. So the sum of the exterior angles in any polygon is 360 degrees. Okay, so again, things in the green box are worth making a note of. So whereas the interior angles of polygons are different for every single polygon, the exterior angles for all polygons, no matter how many sides they have, is 360 degrees. So that's going to be quite useful. So let's just prove then that that's the case. So here we've got a pentagon, a five-sided shape. So let's see what the exterior angles on a pentagon are. Okay, so there we are, there's our first angle. So we've extended the side and the angle between the extension and our angle. We're going to do that again. And down to the next vertex. And another one. And another one. So you can see we've got 5 exterior angles in our pentagon, 5 corners and 5 exterior angles to go with them. Okay, here we've got a point then, so we've got this point in the middle of this cross, and we know that angles around a point add up to 360 degrees. So let's move these angles over and see what they add up to. So we're just going to take our exterior angles, place them next to each other. And there we go. They've completed our angles around a point. Angles around a point add to 360 degrees, so therefore all of our exterior angles must add to 360 degrees as well. So hopefully we've proved then that that's the same, and that's going to happen no matter which shape we choose. All right then. So I want you to have a go at calculating the unknown angles in each of these diagrams. So pause the video now and have a go at finding those angles. Okay, so we should have done for A then 360 minus our 100 and 90 and 90. So remember these squares are 90, and that gave us A as 80 degrees. For this one, 360 minus 60, 55 and 135 leaves us with 110 degrees. And for our last one, 360 minus 95, 72, 83 and 58 leaves us with 52 degrees. So no matter which shape we have, the exterior angles always add to 360. So if we know all but one of them, we can take those away from 360 to find our answer. Alright, so now let's have a look at our regular polygons then. So we know for our equilateral triangle the exterior angle is going to be 360 divided by 3, which will give us 120 degrees for each one. So remember, our regular polygon where all of our angles are the same, so that means all of our exterior angles are the same as well. So we can simply divide by the number of sides or vertices that we have to give us our angle for each one. Once we know an exterior angle plus an interior angle add to 180 degrees. Angles on a straight line add to 180 degrees. So therefore we can work out our interior angle. So if I do 180 minus 120, our interior angle for equilateral triangle is 60 degrees. For our square then, 360 divided by 4 means our exterior angle is 90, and 180 minus 90 is also 90 degrees. For our pentagon, 360 divided by 5, the exterior angle is 72. Our interior angle then, 180 minus 72 is 108. So hopefully you get the idea. We are simply dividing by the number of sides to give us one exterior angle. And once we know one exterior angle, we can use our angle on a straight line rule to find the interior angle. So again, the heptagon is slightly odd. We have a decimal number here. So again, I've rounded to one decimal place. All of the others though give us a nice whole number. So you should recognise these interior angles from the previous lesson. We found them previously by doing the number of sides minus 2 times 180. Well, this is another way of being able to find those interior angles. If we know the exterior angle, or we can work out the exterior angle, then we can use our angles on a straight line to also find that interior angle as well. Okay, if you need to, please pause the video and make a note of those. Okay, so how do we use those facts then? So we've got an example here. The diagram shows a regular hexagon. We need to work out the sides of angles x and y. So it's often easier to find the exterior angle and use that to find the interior angle, particularly if we've forgotten that formula for finding the interior angle. So remember, all exterior angles add to 360 degrees. This is a regular hexagon, so all of the exterior angles must be the same. So we're going to do 360 degrees divided by 6. That gives us 60 degrees, so x is 60 degrees. Once we know that x is 60 degrees, we've got a straight line. We know that angles on a straight line add to 180 degrees. So one exterior angle plus an interior angle must add to 180. 180 minus our x, which was 60, leaves us with 120 degrees. So y is 120 degrees. Pause the video, make sure you're happy with that example, make any notes that you need to. Okay, so it's your turn then. So you've got 2 questions there that are going to check your understanding of what we've looked at in terms of finding exterior angles and using those to find the interior angles. Pause the video, have a go at this in your maths book. Okay, let's have a look then. So the first one, what do the exterior angles add up to? So all exterior angles on any shape add to 360 degrees. How many equal exterior angles does a regular pentagon have? Well, it has 5 sides, so it has 5 exterior angles that are all equal. Work out the size of the exterior angle x. So that's 360 degrees divided by 5 sides means 72 degrees for angle x. Use angles on a straight line to work out the size of the interior angle y. So angles on a straight line add to 180 degrees. 180 minus 72 is 108 degrees for our interior angle. And work out the sum of all of the interior angles. So remember, y is 108, so that means all of these are also 108. So that's 5 lots of 108 degrees, which is 540 degrees. Okay, for the second one then, we're asked to work out the size of the exterior angle x. So it's a hexagon. So 360 degrees for the total divided by 6 is 60 degrees for x. Using our angles on a straight line, 180 minus 60 is 120 degrees for y, and the total interior angles, or there are 6 of them, so 6 lots of 120 is 720 degrees. Pause the video, check through your answers and make sure you're happy with all those facts about exterior and interior angles in polygons. Okay, well thank you for working through today's lesson. Click the link to move on to the next one when you're ready.